Number 17 is kind of taking us back to some stuff we were doing back earlier in Chapter 3. We're being asked to estimate a derivative right here, dt dh. Now, the variables might be throwing you a little bit right here, but t is on our vertical axis where y normally goes. That would be our dependent variable. And then down here, the horizontal axis is h. So what they're really asking us to do here for dt dh is basically similar to dy dx. Basically, guys, they're asking you for the slope of your tangent lines at a couple of spots. The first of which is at h equals 30. So h equals 30 would be right about here. So I'm going to go up to the curve here and say, okay, I'm looking at this point right here, and estimating the value of the derivative means coming up with the slope of my tangent line. So my tangent line at that spot would probably look something like this, but because the units are all weird on this graph, and they did spacing by 50 over here on the side, on the left, it's a little difficult just to look at this and try to figure out what that slope is. So what I'm going to do is try to hit a couple of points here, guys. And in fact, I think I got kind of lucky. Right over here looks like a pretty clean point right here of 0 and negative 100. And then, I'll tell you what, I'm going to talk about my point of tangency here, which looks like it's 30, and then I'm going to guess my y value here is maybe around negative 30. Now, guys, this is a guess. This is not me looking at this saying that's exactly what it is, and that's why they're asking us to estimate here, not asking us to come up with a real value. So, the value of our derivative, dt dh, evaluated at the spot right here where h equals 30 would be approximately equal to, here we go, guys, change in y would be negative 30 minus negative 100. That's negative 30 plus 100, which is 70. And then our change in x, or our change in h on the bottom, would be 30. There we go, 30, and minus the 0 would be roughly that. So I'm going to come up with an answer here of about 7/3, but if you got an answer that was anywhere close to that, like for example 2 is relatively close to 7/3, I think that'd be a pretty acceptable answer. When they're asking you to estimate, and especially with points that you're just kind of eyeballing, there is no one right answer. Now they want us to do the exact same thing again, come up with an estimate for the value of dt dh, but this time now when h is 70. So let's, I tell you what I'm going to do here, guys. I'm going to change the color of all of that. We'll go to this lovely shade of purple here, and then let me do the same thing with this pen now. So it's 70, 50, 60, 70, which is right here. All right, I'm going to erase some of that tangent line that I came up with right there, and when h is 70. It looks like we have a point of tangency maybe right about here. Now our tangent line is going to look something like this. Boy, and it really looks to me like that's maybe just the, what would that be, guys? Just the opposite of the slope that we came up with. I'm going to say that this point right here looks like it could very well be 70, and I think we're at maybe the same y-coordinate before of negative 30. Okay, and what else am I hitting right here? Again, this is just a guess, but I might use maybe this point right here, guys, which looks like, oh boy, it's between 100 and 110. I'm going to guess it's 108, sure, but a y-coordinate of 0. So let's see if we can get this one to pan out and what it's going to look like. Change in y, I would go with 0 minus the negative 30 right there. Wait a second. Oh, I realized my mistake. That didn't sound right to me. That is not a y-coordinate of 0. Oh boy, on that graph, this was 0. Here was negative 50, negative 100. That's maybe about a negative 150. Okay, glad I caught that. So negative 150 minus negative 30, that's plus 30. That would give me about negative 120 there for change in y. And change in x, 108 minus 70 is going to be what? 38. And that doesn't simplify by much here, guys. That's a negative 60 over 19, which is ugly, but I want you guys to realize that value right there is relatively close to negative 3, and then this slope value that we came up with up here relatively close to positive 3. So I was kind of right close in my assumption right there that those two slopes were just opposites of one another. Now, one more thing, guys, so let's go to green this time. They're now asking us, where is dTdh equal to 0? So again, they're asking us to look, oh, I've written all over the place. All right. They're asking us to take a look at the red curve here, guys, and figure out where the slope of your tangent line to that red curve would equal 0. And it kind of looks like, okay, when our slope is 0, we have horizontal tangents. It kind of looks like that might happen right here on kind of this extended interval from here to here. So let me go ahead and try to answer this as best I can. dTdh is equal to 0. I would say on the interval right here that looks like it starts at maybe about 12, a little more than 10 right there, but less than 20, and ending right over here at about 22. That's just a guess, but okay. I think I've got another horizontal tangent right there. That looks like at about the spot where h is equal to, yep, just about 50. And, oh boy, that kind of looks like a spot of non-differentiability, but we're going to run with it for now. Let's see, 60, 70, 80, a little bit less than 90, so maybe I'd say where h is equal to 88 if, in fact, that red curve is a continuous function. So all of these are estimates here, guys. I'm not even sure what they have for their answer, but probably pretty close to what we've come up with here on number 17.